These few slides will explain hypothesis testing. And so as you view your data and develop a research publication and develop your presentation, I just want to review hypothesis testing. So the research approaches are varied. For example, historical research, descriptive, qualitative research. We in kinesiology and exercise, and specifically exercise physiology, it's probably more experimental research. And the general nature of the research problem or the research question will determine which approach you will use. So the hypothesis, it's most important to research studies, and it's a tentative explanation of the outcome of the research problem. So what do you think is going to happen? And again, as I described on the earlier slide, in some areas of kinesiology, there may not be a specific testable hypothesis. So some descriptive studies, they may not state an hypothesis. There may be a list of objectives or aims of the study. But for the most part, the papers that we've been reading and the research that you've designed, you want to have a testable hypothesis. So I copied this from Research Methods book. And so in general, research hypotheses, these describe a research hypothesis. So it's not a simple guess. It's an educated guess. It's an idea of what you think is going to happen. And this is based on literature review. So it's based on theory, it's based on previous research findings. And it's a relationship between different variables. A research hypothesis is simple and it's clear with no vague terms. So the training group will perform better. Well, what does better mean? No, it's going to be a very clear, specific statement of a significant increase in power output. There, we know what power is. That's defined. And they're testable, so we can test differences in, for example, power. They have the capability of being refuted. So yes, it occurred. No, it did not occur. And they're related to available techniques of design, procedure, and the statistical analysis. So you may have seen these before, or other classes described these before, but this is a good review of what is an hypothesis. And again, it's an educated guess, not just a guess, or not just, you think this may happen. No, it's based on the literature review and based on theory, previous research. That is the research hypothesis, and that's what you are thinking about. Statistically, you need to change this research hypothesis into the null. And so the null or statistical hypothesis is when you're predicting there to be no difference in the conditions, or no difference between the variables, or no difference, in the training program, for example. So hypothesis, which says that the independent variable, the one that is being manipulated, has no effect on the dependent variable, the variable that you're going to be testing. So there's no difference. This does not necessarily reflect your expectation. You, the researcher, you're expecting, that's your research hypothesis. This is what we think is going to happen based on previous literature and previous research. And the null hypothesis is this statistical testing hypothesis. So this is done so you can do the statistics, and the results of the statistical test will enable you to either accept or reject this null hypothesis. And the purpose of this statistical test is to evaluate this null and at a specified level of probability. So all the papers you've been reading, and you've seen this before, we've talked about this before, but typically you'll have some kind of p-value, and that p is for probability. And typically in experimental research, there's a p-value of 0.05. And that's not always the case. It does not have to be the case, but that's sort of a typical value. So do the values of the dependent variable differ significantly, p less than 0.05, so that these differences would not be attributable to chance occurrence of more than 5 times out of 100. So that's a probability. Are you willing to accept that, you the researcher? And typically an experimental researcher, in research that we are accepting that. Some papers that you see, they may actually give you the p-values. They won't say p less than 0.05. They'll say p equals 0.02 or something. So if the null hypothesis is accepted, then the researcher rejects the research hypothesis. So that and concludes there's no difference between the groups. If the null hypothesis is rejected, then you're going to accept your research hypothesis. Great. So an example of a research hypothesis, it is hypothesized that children taught by teaching method A will perform better on reading achievement tests than children taught by method B. I actually copied this from a book. I don't know if better is the best word choice. But maybe some measurement of what we define as better. But you get the idea. It can be, there can be direction of the expected results. So a directional hypothesis, meaning, for example, a training program will increase power output. So power output's going to go up. So that's a specific direction, of course. So children with higher IQ are more easily motivated than children with lower IQ. A non-directional hypothesis, when the researcher has no reason to believe a particular relationship or difference exists in any direction. So you know that exercise training is going to make a difference, but you're not exactly, sure how. Or altitude training is going to make a difference in VO2 max, but you're not exactly sure how. So there's a difference in the motivational level of children with high IQ versus low IQ. So there is a difference. We don't know which direction there is. So there will be no significant difference in reading performance, so that's a good measurable term, between students taught by method A versus method B. Or teaching method has no effect on reading performance. And here I copied this out of a research methods book. So there's the definition of a research hypothesis. And this is looking at caloric intake and BMI. So those are measurable. And the null hypothesis is that there's no difference in caloric intake and BMI and after having participated in a nutritional exercise program or nutrition program. So research and null hypothesis. So a rule of thumb, research which asks a difference or relationship. These kind of questions should always have an hypothesis. So is there a difference in power output pre and post training? That's a difference question. So there must be a research hypothesis. Research which is descriptive with no comparison across groups may not need a research hypothesis. Remember, you don't prove something. So the results of your study are not going to prove something. You're going to reject or fail to reject the null hypothesis. So just a couple different notes on hypothesis testing. And when you develop your publication and your presentation, make sure you're aware of and review research hypothesis testing.